The first thing you have to do when graphing exponential functions is to identify certain characteristics of exponential graphs. This kind of functions will always be represented by y, and will always have an horizontal asymptote that crosses through the y-axis, and you can identify this asymptote by the left constant in the equation. Also, it is important to mention reflections and asymptotes that exponential functions have. An exponential function will always have an horizontal asymptote through the y-axis, and the reference point will always be 0, 1, and of course it will be increasing. In case of having a reflection in x will always be totally reflected over the x-axis. So if you have the reference point 0, 1, it will only be reflected over the x-axis, exactly the same. Identifying y-axis reflection is when you have a negative sign in front of the exponential number. So if the reflection in x is reflected over the x, the reflection in y will be reflected over the y. So if you have the parent function that goes increasing, you just change the side over the y-axis and it will be an increasing graph now. It is important to mention that if you have a number between 0 and 1, you will always as well have a reflection in y. So there's two cases of reflection in y. For example, a decimal or a fraction which the denominator is bigger than the upper number.
One example of this will be the following equation. F of x equals 2 to the x minus 3 plus 1. The first thing we have to do is to identify the asymptote. In this case, as we previously mentioned, is this number right here. Therefore, the asymptote will be y equals 1. Now, the next step will be to identify the key point of the graph. Since this is the origin point of exponential equations and it is a positive, we will translate 1 up, and we will translate 3 to the right, since this has a horizontal translation, 1 up and 3 right. Now, since as I said, this number right here is positive and bigger than 1, it is not a decimal nor a fraction. This is also not negative, therefore it should go up. Another way to identify where's the graph moving is to evaluate a point. For example, we can evaluate the number 6, x. And when evaluating 6, we will get y will be equal to 9. Therefore, we can assure that the graph is going up.
In April 26, in 1986 in Moscow, occurred the Chernobyl disaster, which was a nuclear accident caused by a situation blackout and a power failure, in which safety systems turned off. Apart from the damage caused by fires and explosions, accidents also release radioactive materials which can cause radiation sickness. Radiation exposure, usually only received by workers and emergency teams, causes radiation syndrome within hours of exposure. Depending on the dose of radiation, this can cause skin rashes, vomiting, and diarrhea, to coma and death. To today, the radioactive air is still present and hasn't been able to eradicate completely.
Now, we will overview 2 examples of exponential graphs in real-life situations. Okay, rabbits population growth. A real situation. The population of rabbits has been increasing exponentially for the past years, increasing by 200 each year, and it continues to grow. In this case, the equation that represents this will be 2. This represents that the amount doubles each year, and 5 represents the initial amount of rabbits. X represents the amount of the passing of years, since it grows exponentially. Now we will start graphing. First of all, we should take into consideration the asymptote, as we learned in the graph explanation. In this case, since there's no value in here, the asymptote will be y equal to 0. And the key point will be 0,5, because this 5 is affecting the whole graph. Now, if we evaluate for x, we can notice that the graph starts growing exponentially. When 0 is equal to 5. After 1 year, the population grew to 10. After 2 years, that population grew to 20. And so on. Another example of exponential growth will be this. This is a hypothetical situation. Leaves falling from a tree. The amount of leaves falling from a tree doubles each week. The initial amount was 1 leaf. The equation could be represented as f of x equals 1, where 1 equals the initial leaf times 2 to the x, which x equals means the amount of weeks, and 2 means that it doubles the amount. If we start graphing with a table of values, we will have this, that when x is equal to 0, which is the initial key, because there's no number in here affecting the graph vertically. Therefore, this is the initial key. Then, when I mean 2 weeks, the leaves fallen would be an amount of 4 here. When there are after 4 weeks, 16 leaves would have fallen in here. And then after 14 weeks, the amount would have increased into 16,384, which is a lot. Would be somewhere here. We can conclude that this graph grows exponentially, has an asymptote of y equals to 0, and a key point of 0,1. And it is going up because here is bigger or equal to 1 and is not negative.
An exponential growth is when rate becomes even more rapid in proportion to the growing total number or size.
The function of exponential growth is to show rate at a rapid proportion, which is represented by increasing line. What are the main characteristics? Exponential decay is when the total value decreases but the population that lives remains constant over time. Contains horizontal asymptote, characteristic point 0,1, base between 0 and 1, reflection over the y-axis, base greater than 1, and steepness changes. The problem of radioactive waste is still an unsolved one. The waste from nuclear energy is extremely dangerous, and it has to be careful looked after several thousand years. Nuclear energy is by far the largest source of electricity that doesn't emit any air pollution. It has a major role in protecting America's air quality. So yes, we consider nuclear energy as a clean energy. We should consider a possible danger when using it. The one and only Laguna Verde nuclear power plant is located in the Gulf of Mexico, in Veracruz, which nowadays is property of CFE. We believe every nuclear plant is totally safe, and every single one of them has its risks, especially in our country, since earthquakes are suffer in that specific area. Although we agree with the fact of having a power plant, since it produces 4.5% of the country's electrical energy.
Yes, this disaster was caused by the series of mistakes made by the own workers of the plant. The experiment was made very late at night, with unprepared people and material. This could have been prevented if the experiment would have been postponed and the materials had been double-checked.
No, the explosion couldn't be stopped. The only thing they could do was evacuate the place before the radiation started to affect anyone's health. We totally disagree that the radioactive pollution generated by that disaster reached Mexico.
since the area polluted only reached some areas of Europe.
An abiotic factor is that some of the elements with long half-life, like plutonium, were slowly absorbed into the soil. An abiotic factor is that when the accident occurred, flora and fauna of the community were affected and caused birth mutation on 1 of 10 animals. 400 hectares of trees were killed, forming the famous Red Forest. Rare species like wolves and bears moved into exclusion zones.
Millions of people can die. Millions of flora and fauna species can die and mutate as well.
We feel very sad about the innocent people who, without they even knowing, were being affected by this radiation. A possible solution would have been to evacuate as soon as the plant exploded.